When we think about construction in Malaysia, it is easy to focus on the immediate headaches. We hear the constant noise, we see the dust coating our cars, and we experience the heavy, muddy flash floods that stall traffic in Kuala Lumpur. Beyond the local traffic jams, there is a global climate reality. The construction industry is responsible for nearly 40% of all carbon dioxide emissions. The concrete we pour and the steel we forge represent one of the single largest contributors to global warming. This infographic maps the framework civil engineers use: sustainability. It's a system moving away from building cheap and fast toward balancing the environment, economy, and society. It means meeting today's needs without depleting the resources our grandchildren will need. As diploma students, you are entering the field at a turning point. Your daily decisions on site will determine whether Malaysia continues to deplete its resources or begins to actively preserve them. Protecting the planet starts long before the first shovel hits the dirt. It is a process of technical prevention built into the planning phase. One major tool is the EIA, or Environmental Impact Assessment. This is a mandatory study to predict how a project will affect local habitats. If a proposed highway cuts straight through a vital forest, the EIA requires the design team to curve that route to avoid the trees entirely. We see this with the East Coast Rail Link. Because of the impact study, engineers designed elevated tracks and tunnels that act as safe corridors. These allow local wildlife to pass safely underneath without being cut off from their natural habitats. Once active construction begins, heavy rain can wash loose soil from a site and choke nearby rivers with mud. To stop this, teams use an erosion and sediment control plan, building specialized basins and temporary fences to trap mud on site before it reaches public drains. Engineers also use the industrialized building system to cut down physical waste. By manufacturing walls and pillars in a controlled factory environment and simply assembling them here on site, they reduce material waste by up to 50%. In civil engineering, environmental protection is a rigid system of technical prevention and material efficiency. Next is the social side of the equation. A massive project is only successful if it improves the safety and daily quality of life for the community using it. Kuala Lumpur's Smart Tunnel is a specific engineering model designed to solve two social crises at once. On a normal day, it functions as a multi-level toll highway. This pulls thousands of cars off surface streets, reducing the traffic congestion and daily stress for commuters heading into the city center. But during a heavy monsoon, the road closes to traffic entirely. In a matter of hours, it transforms into a massive drain, catching up to 5 million cubic meters of floodwater and diverting it away from downtown. Social sustainability requires infrastructure that can adapt. It is about designing structures that actively protect citizens from the escalating impacts of climate change. The final piece is the economy. Think of construction like buying a smartphone. You can buy the cheapest model available, but if it breaks in a month, you spend more money replacing it. A premium phone costs more upfront, but it is built to last for years. Engineers use a tool called life cycle assessment to calculate a building's true cost from start to finish. They map out every expense and energy requirement that the structure will demand over a 50-year lifespan. Installing solar panels, high-efficiency lighting, and quality materials definitely increases the initial construction budget. But over 30 to 50 years, those choices save millions of ringgit in utility bills and frequent repair costs. Sustainable engineering is a long-term financial strategy. Maximizing the total value of a project is the most viable way to manage the cost of ownership. To ensure these goals are actually met, the industry uses grading systems. You can think of these as a strict CGPA, but for buildings. This chart outlines the major tools used in Malaysia. We use MyCrest to track and lower carbon emissions. The Green Building Index grades energy efficiency for commercial towers, and the PHJKR rating ensures government infrastructure is built to stay cost-effective over many decades. But these ratings only matter if they are enforced. Soon, you will be the professionals working under the Malaysia Board of Technologists or the Board of Engineers. Mastering these sustainability standards is the most important skill you can develop. It is the technical knowledge you need to build a resilient, future-proof Malaysia.